let's go through this. All right. So I'll start. Every year, more than 1 billion people contract a parasitic illness. With 7.6 billion people on the earth, odds are one of us in this room is currently carrying a parasite. Over the past decade or so, we've learned that the microbes which live inside of us underpin our health, behavior, emotions, and even the foods that we crave. Recently, we learned that microbes can also influence the likelihood of acquiring a parasitic infection and may even alleviate the severity of the illness. Some parasites alter the microbial communities of their hosts in a way that benefits the parasite. What is not known is if parasites carry their own microbes, independent of their host environment. We don't really know that much about bacteria inside the parasites themselves. My research is focused on a parasite often heard about in Hawaii, Angiostrongylis cantonensis, commonly known as rat lungworm. Angiostrongylis is a parasitic roundworm, the causative agent of a potentially fatal emerging infectious disease known by the same name, rat lungworm disease. I propose using Angiostrongylis as a model species to investigate if parasites carry their own microbes, and if so, how does this influence transmission to humans? To do this, I will use 16S rRNA gene to identify the microbial community inside of the parasite, as well as the microbial community within the host. Angiostrongylis has 2 hosts, both necessary to complete the life cycle, rats and snails. At each stage of the life cycle, I will compare the microbial community inside of the rat lungworm to the microbes in the snail and rat tissue where the rat lungworm larvae are extracted from, and then evaluate those differences. Why is this useful? I'll tell you. Describing the bacterial community inside of Angiostrongylis is not only novel, it could direct targeted approaches to treating rat lungworm disease in humans by identifying a microbe necessary for rat lungworm's development and survival. For example, it was recently discovered that a bacteria, Wolbachia, is necessary for a different parasite, a filarial worm, to survive. Now, treatment of this filarial worm is focused on killing the Wolbachia that lives inside of the parasite, indirectly killing the parasite. So with this in mind, applying the microbial aspect to my current graduate research will strengthen my overall investigation of this parasite-host relationship. And if my research detects a microbial structure inside of the rat lungworm that is not found in the snails or the rats, it can set the stage for exploration into other disease-causing parasites and their microbes. Had one more line. It's close. Yes?
Great, I like it. It's really interesting. It kind of took a whole spin I wasn't expecting, actually, the microbe of the parasite in person.
Yeah.
That's neat. So along that lines, have you thought about perhaps keeping the samples or actually identifying the immunological response in your samples as well?
Actually, that is something that I've considered, and I've talked with my committee about looking at. Oh, yeah. Sorry. Okay. Thank you. Yes, I've considered this prospect with my committee, looking at transcriptomics and the expression of certain proteins related to the immune response in the snails and possibly the rats as well. Yeah, I think that's a very important step in identifying what's going on in the host, so the rats and snails after infection. Yeah, I haven't applied any of this yet, but it's something that we talk about adding into my project. Yeah. Yes?
How do you control for natural variability of microbial communities inside the host, or inside the parasite and the host?
Control for natural variability inside. So having a large enough sample size, I imagine, would help me evaluate what microbes, what the differences are just natural fluctuation as opposed to a core community that's found throughout all of the larvae, all of the rat lungworm, and then in the hosts.
Have you done a lot of DNA extractions in qPCR and stuff before, or would this be new?
Yeah. No, that's a really good question. So I'm a little bit older than I think the average grad student. I spent over 3 years working in a molecular diagnostic lab where I extracted DNA and ran next-gen sequencing every day. We were doing cancer prediction. And so I have a lot of experience in an industrial setting, and then in grad school, I run DNA extractions, PCR, qPCR. I've screened many snails for rat lungworm on Oahu. So this year, I've done survey work with snail populations and screened over 1,000 samples. And so I do have experience with that part of the molecular work, yeah. Yes?
I actually have two quick questions. I find rat lungworm absolutely disgusting. So please.
I apologize.
The first question is, what kind of biosecurity do you have for your experiments? Because it's terrifying to me that you're going to be working with this with your hands.
So that's a really good question. I'm glad you asked. So I do wear gloves. I do use PPE, and the rat lungworm is contained in a BSL-2 lab. So precautions are taken, and it is not, the larvae are large enough, they're not aerosolized. So you can't breathe them in. So it actually needs to be an ingestion, whether inadvertently by having it on your hand and then licking or wiping your face. So all precautions are taken. And I actually wrote the protocol to get approval for this project. So yeah, good question.
My second question is, what kind of sample size do you have?
What's our sample size? Yeah, so currently I have samples from my field collections. So I have over 1,000 samples from field collections. But what I would like to apply this work to is my experimental phase. So I have colonies of 3 different snail species that I'm raising in a lab. And I'm experimentally infecting them with rat lungworm and then observing their behavior and effects on their life history. And so I would use those. And my sample size is 36 of each species. And I think I can take it down to about 5 or 6 of each species. And then, so I want to use different species to compare the larvae. And then with each stage of the larvae, I would want at least 5 of each L1 phase. So juvenile phase, adult phase in each snail. Yeah. Yep. Thank you guys. Mm-hmm. Okay, so is my project scalable? Yes, so I proposed looking at, so rat lungworm, the larvae develop through 5 stages. And ideally, I would like to look at the microbiome at each stage of the larvae to identify differences to target developmental necessity of these microbes. However, only one stage is infectious to humans, the L3 stage, and it's completely feasible to start with just the L3 phase and look at the microbial community within that stage and then the host. So yeah, it would be about 1/5 of the project, and that would be doable.